Folks, I'm going to do this one last short clip pertaining to categorical syllogisms. We've already looked over the Venn diagramming test for validity. We've seen an array of examples. We've also done the rules method, and we'll look at some more examples there. The last thing I want to broach, and by the way, the reason why it's the last thing I'm broaching is because I would prefer you do not use this method at all. Because this method it's sometimes called the counterexample method or the counterexample test. And by the way, folks, it cannot test for validity. It can only verify invalidity. It can only verify invalidity. Now, this counterexample test, if you prefer, you can think of it as a sort of substitution method. Because what we do when we apply this method, if you had a mood and figure of a syllogism, what you would then is construct premises and a conclusion that are consistent with that mood and figure. And then what you have to do is make sure that your premises are true, and then you call the question, is my conclusion true or false? Now, if, folks, you find that you've got true premises and a false conclusion, it's a no-brainer what you can conclude. Because remember that definition of deductive validity. It says, if an argument is valid and its premises are true, its conclusion will follow by necessity. Now, I don't want to be a pain in the butt here, but I will be. Now, notice that by modus tollens, so if an argument is valid and the premises are true, then the conclusion will be true. Now, what if it's the case that the conclusion isn't true, but not C? Therefore, you know it's not valid. That is the reason why the counterexample method works as a test for validity. Invalidity, excuse me. I just gave a deductive proof for why it works. The problem is, it cannot confirm validity. It can't confirm validity. That is why I don't recommend that you use this test, because there are chances that you will get a false positive. In other words, excuse me, an invalid form with true premises that might churn out a true conclusion. And guess what I'm bringing you? I'm going to give you an example in which this is exactly what happens. Here's the example. I think we may have already seen this mood and figure before, but no matter for that. Let's conjure up an AII2 syllogism. Many of you already know why this one is invalid, simply via the rules method, which we've recently gone over. And we can review that in a minute. I first want to show you why the counterexample method test doesn't necessarily work very well for proving this one to be invalid. Suppose we've got the statement, all grasshoppers are insects. As far as I know, that is a true statement, because this is part of this class. Now, the deal is you have to use this method at all, you have to make sure that your premises are definitively true. And that's not an easy thing to do, because I've seen folks do this on homework assignments time and again, and this is no insult. I've seen students do it time and again on homework assignments where they will try to make their premises true, and I can say, you know what? That's really not necessarily a true premise. If you say, all conservatives are anti-abortion. Well, that's not necessarily true. I have libertarian friends who self-identify as conservatives, and they think hands-off ought to be the government policy. So my long-winded point here is, when you have labels that are sufficiently large, it's difficult to actually make definitively true premises. That's why I always stick with things like wallabies, marsupials, mammals, etc. when I'm trying to make definitively true premises. It's the pathway of least resistance. Now, I'll shut up about that. My next premise, because it's figure 2, insects has got to be here. Some flyers. Flyers means things that fly, just in case. Sounds weird, sounds awkward, but it's the category of things that fly. Some flyers are insects. That's true. Now notice I can't say all flyers are insects. That would be false. Because we got birds, we got airplanes, etc. Now, since we said this is AAA1, or 2, excuse me. All right, and to reiterate standard form, how I knew where these go, remember, if it is not the middle term and it's in the major premise, it's the major term is the predicate of the conclusion, and the minor term is right here, which is the subject of the conclusion. This is just to reiterate. Now, if the counterexample method were a foolproof method, anytime I had true premises and it were invalid, it would spit out a what? A false conclusion. Look what we have here. True statement, all grasshoppers are insects. True. Some flyers are insects. True. Therefore, some flyers are grasshoppers, which is also true. But I know that this is an invalid form. How do I know it's an invalid form? Rules method. I know that this one's invalid because of an illicit middle term, aka an undistributed middle term. If a syllogism is valid, the middle term has got to distribute in one of the premises. A statements do not distribute predicates. I statements don't distribute subject or predicate. So I know that the middle term doesn't distribute. So this one's invalid. But the counterexample method didn't tell me that. This is why I recommend folks don't use the counterexample method. You can get false positives. How about I give you one more? This is another one that you've seen is invalid, also because of an undistributed middle term. So I guess I better not give you this one on the test. AAA2 is invalid. All cows are livestock. I would say that's generally true. I guess they have pet cows and someone might not define them as livestock, but we'll pretend that's not so. All pigs are livestock. Therefore, all pigs are cows. Now, this is a clear example where the counterexample method does work. We've got true premises and we've got a what? And our conclusion is false. The counterexample method demonstrated that this one was invalid. Now, folks, you probably know what would happen if you have a valid syllogism. If you have a valid syllogism and you plug in true premises, a true conclusion will come up every single time. But that's no proof that it's valid, because I showed you a moment ago that sometimes we get false positives. So even if you went through 3 or 4 examples where you fill in terms and you get true premises followed by a true conclusion, that would not be full deductive proof that that syllogism is valid. However, you would be making a strong inductive case, reviewing. You would be making a strong inductive case that the syllogism is probably valid. This method cannot prove validity. It can only prove invalidity. However, using the counterexample method, true premises, true conclusion, and doing it a fair number of times can produce an inductive argument for believing that it's valid. Now, you know why I don't recommend you doing that? Number one, because it's not foolproof, like diagramming or using the rules method. The other reason is, think of how much time it takes to creatively make up true premises. That's not the path of least resistance. And if you're like me, you would prefer to use the quickest, most foolproof method rather than this haphazard trial and error method. So this is why I recommend you not use this method. However, if you're having difficulty and struggling using the other methods, this one is certainly something you could use in a pinch, but I certainly would not recommend it. Now, I hope that I've made clear how this method works and also why I'm recommending that you do not use it. Cheers to the counterexample method.